Yeah, so right here we are. You might be wondering about how water gets to where you're at. When you go home and you open up that faucet, right? And you might wonder about how that water's getting here. So we brought you out here today to show you here in our very own backyard. We're actually in Spring Valley in the Sweetwater Reservoir right behind us. On the other side of this body of water, we have the treatment plant where they actually they take this water, they clean it up, and then they send it up to containers like this one up here, which is called the standpipe. And right there, after they clean up the water, they pump it up right there, and it's stored right there, and then it's sent out through all the pipes, through the infrastructure, out to the different and local homes. And so throughout San Diego, you'll see a lot of different standpipes that look like that, or they may look taller, or they may look shorter and wider. But essentially they all do the same thing. They store the water that's been treated and is ready to drink. So during the day when everybody's using water and that tank is going lower, they will fill it up at night when it's cheaper to do so, because it requires energy to send it from the plant that's being treated at up to being stored in these containers where it's ready for distribution later on. Hey friends, welcome back. Still Beto here, and I'm here to talk to you today about water. But we're going to continue the conversation about water. We're just going to keep it flowing, right? You know, I'm reminded of one time I had a conversation with a good friend of mine who was visiting from out of town, and we showed our friend around, and we, went and seen different places and did different things. And when it was time for my friend to return home, I asked him if there was anything that he wanted to take with him, anything that we could give him on his journey. And he turned around and he pointed at a faucet. And I was confused. And I said, "What do you mean a faucet?" And he said he would love to have the ability to turn the lever and get water just like that. Now, this is something that we take for granted a lot here in the United States, that a lot of other underdeveloped countries don't have, which is infrastructure to bring water from very remote places just to you in your own home. So today what we're going to do is we're going to continue the conversation. We have a model house here that we're going to show you, and we're going to show you how water system works, not only from what we've seen already, which is the standpipes and the reservoirs, but how it's making its way into your own home. And to give you a model of this home, we've gone ahead and put together this impromptu water system, right, which is supposed to represent how the water comes in from outside, from the city plumbing into your home through your own plumbing, right? And so what happens here is, as we saw earlier already, in these big containers where water's kept after it's been treated for drinking or made potable, as it's called, what we have is a system that's driven by a force that we interact with every day, which is gravity. Now think about it. If I were to ask you how much 1 pound of water weighs, many of us probably wouldn't know. But a pound of water weighs a little bit over 8 pounds. Now, if you think about how many thousands of gallons of water are in many of these big standpipes that we've seen, or these reservoirs, then you can imagine the amount of force that's exerted as it makes its way from larger pipes to smaller pipes as it gets to your home. So today's example that we're going to show you is we've set this system up right here with 1 gallon of water that's going to put that 8 pounds of pressure through these smaller pipes, and we're going to check the flow that it has when it reaches different faucets throughout your home. So down here, representing the first floor type of thing, we see that faucet there. We have another first floor, but away. That one's a little bit further away from the source of where the water's coming in. We have one that's closer to it. And then we have this one that represents kind of the second floor version of that here. And on this one, you're also seeing a leak, which was, I want to tell you it was intentionally done, but it really wasn't intentionally done. But it's okay, right? Because I think it's representative of what we see. We see a lot of leaks sometimes, and if you look around here, you'll see that there's a lot of wasted water happening. We don't want to do that here, especially in the Southern California area. But we also want to show, we're going to demonstrate, because we're going to measure the force that which it comes out. We're going to demonstrate what a leak like that has an impact on the force of the water that's coming out, or the pressure. All right. So if I were to just tell you, hey, turn on the faucet, right, at home when you're brushing your teeth or when you're washing dishes, you would notice that sometimes you turn on the faucet, right, and there's a lot of pressure that comes out, meaning the water comes out super fast. Sometimes we like that because it's easier to spray off maybe some of the food that's on your plates. Maybe you just like to wash your face a lot faster. Maybe when you're taking a bath, you like, or shower, you like to have more pressure, right? But really, when we're talking about pressure, is we're talking about how much water is coming in through that smaller surface and coming out the other end, right? So as we're thinking about how the water comes to your home from the city system, or the water district system, you'll see a line that comes from the street into your home, usually one line that's doing that, and it goes to a little thing called a regulator. And so the regulator helps to regulate the amount of pressure that's coming in, that the water's coming in from that general line into the system for your home. And so with that regulator, you can adjust how much pressure, if you want more pressure, if you want less pressure. Now remember, if you have higher pressure, you're going to be spending more water because it's going to be coming out a lot quicker. The velocity is a lot faster. So today, rather than just telling you, hey, look how much water, how fast the water's coming out, we're going to use this little valve here, this gauge, better said, excuse me. So what we're going to be using today is this flow meter, which helps to measure how many pounds per square inch, or how quick the water is that's coming out. Now, I got to be completely honest with you. I'm not a professional using these, but it's fairly easy to use. You take this, you connect it here, and you turn on the valve, and this gauge should then move to tell you what the PSI is, the pressure that is coming out of this bib here. So when you use this, because it is manual, you want to make sure that after it goes up like that, that you recenter it or calibrate it again so it could be ready to use for the next time. So let's go ahead and try it out and see what happens here. And this thing here cost about, I don't know, about 10 bucks over at Home Depot. So let's see what it measures coming out of our makeshift system. Remember, we're using 1 gallon, which is like, well, it's probably like halfway now. So it's about 4 pounds or so of weight of water coming in through this 1/2-inch pipe that we're using here. So let's see what happens. So really didn't do much. Really didn't do much. Now, this might be because maybe we just don't have enough weight that's going on here. So let's see what happens. Maybe if I add a little bit more water, this might help. And so I'm using this bottled water right now because I want to make sure of how much measurements I'm using. Sorry about that. Almost got our cameraman whipped there. All right, so nothing's happening, right? Again, it could be because it needs a continuous flow of pressure that's going on. It could be because it's open at the top, so it's kind of equalizing right now. Not really sure why it's not participating the way we want it to. So let's see here. Okay, so there is water coming out. Just wanted to make sure. We're going to zero that out again. I'm going to put this on once again, and hopefully, even if it moves a little bit, I'll just be happy because this little makeshift system of ours is actually working. So let's give it a shot. Nope, not working here. Well, in an ideal setting, as you saw in the clip earlier, you would notice that the pressure's going up. But let me try one of these other spots over here, and we'll try the one with the leak and see if anything perhaps is happening here. Nothing here. And again, it could be because of the leak. It could be, there's a lot of different variables, we call them, of why things wouldn't possibly be working here. Let's try one more time right here, just in case, before we go troubleshoot whatever it is that we need to do. All right, so we're back. So we're actually at my house. I'm checking the system right here. We couldn't get the little house to work, the model that we did. So the next best thing is to show you what it actually looks like in the home. Now, remember earlier I told you about the regulator that actually helps to regulate the pressure that goes into your house? Well, this line here actually comes from the street. And then this, excuse the cars there, this is actually what they call the shutoff, right? So if ever you have a plumbing situation in your household, you would come here and turn this lever slowly up like that so that it can stop the water from coming into the house, right? This line continues to go in the house. It goes to this regulator here, which regulates, and we changed this not too long ago. That's why you have this gaping hole right here. But it regulates the pressure that goes in. And ultimately, this is the first bib that comes out, the first faucet that I'll be able to get pressure on first. So if I turn it on slowly, we'll see nothing there. You see the pressure here is a lot higher, and the reason you saw that right now is because this line, the main line down here, was actually not on right now. So as soon as I turned it on, it allowed for all the water to come into the household, and it gave me my first reading here, which is right here. Let's try that one more time. There we go. So we have initially close to 50 psi as the water's coming in, or is that 70? We'll have to look right now to see what the flow meter needles indicate. Very important to be able to do that so you can understand what you're working with here. So while we go check that out, we'll take the readings on the back of the house. So you'll actually notice that there's some gradual movement here. That's because somebody inside the house is either washing the dishes right now, or the washing machine is running, or somebody's flushing the toilet. So while those tanks fill up, or while they're using that water, this is gonna adjust here, and then it'll go back to what it initially was. So we're going to show you how we've improvised to be able to show you how water travels around the different faucets in your household by being able to turn on the small ones and then the ones that are representing the second floor, and then we're going to turn on that third one back there so that we can show you how the water is going to always take the path of least resistance, right? And so since the lower ones require less pressure, then we're gonna actually change to that. So what we're talking, you might just think we're talking about water, but really what we're talking about is a bunch of physics that's happening right here. And that's where engineering and physics comes into play in how we build these systems that are able to bring that water to your tap at your home for your convenience. So here we go, we're gonna get started. We're working with 1 gallon once again, right? We'll go ahead and get this one started here. So we're relieving some of the pressure. Go ahead and start that second one there on the top. All right, so we see a nice flow going on, and go ahead and turn on that third one there on the bottom. And it seems that immediately, as soon as we turned on the one on the bottom, we saw that the pressure that was up top definitely was a lot less. So we have a strong chorro going on right there, and we have less of a robust eruption coming from that one there. So again, nice flow there, nice flow here. Water's all done now. All right, so we're back. So what did we learn today? So today we learned, for the most part, where our water's coming from, right? And we learned that having the luxury of actually just turning on a faucet near us requires a lot of work and a lot of science. So if we want to continue to be able to have that privilege of accessing water at our disposal when we want to brush our teeth, when we use the toilet, when we want to drink water, when we want to feed our animals a little bit of water, then we want to make sure that, one, we learn to conserve this very precious resource that we have little of here in Southern California. And I want you to understand how these water systems work, right? So we started off at the reservoir. We've seen how it goes through treatment. We saw how it goes through a distribution system where it's kept after it's cleaned and been and made readily available for you to use. And then we kind of followed along what it looks like when it comes to your house. And I want you to understand that it goes from big pipes to a lot smaller pipes, and there's like thousands and thousands of pounds of pressure because of the weight of water, which again is about 8 pounds a gallon, that's causing this gravitational force onto these little pipes. They get smaller and smaller and smaller, allowing for us to be able to see what that pressure is when we turn on the water, right? And so we got to, although our little house kind of disappointed us because it didn't do the readings quite like we thought, that's science. It's okay for things like that to happen. We did the next best thing, and we actually took readings here at my home of where the line comes in from the city line, and then the midpoint, and then the furthest point back. And we saw that the pressure, for the most part, is a little under 60 psi, which is okay. If it was above 80, then it would be something to kind of take a look at and something to address. But don't take advantage. Don't take it for granted. Definitely that we have such a valuable resource at our availability here at home. Thank you very much for following along. I hope you learned something today. Follow us for next time to see what else we get into. Bye-bye.